My name is George Bell. The Whitehead Institute is where I work. It's a great place to be, fantastic science with many a perk. We're in Cambridge, MA, affiliated with MIT. If you want to do biomedical research, there's no better place to be. We're Bioinformatics and Research Computing, better known as BARC. We support 20 or so labs, I should be sure to remark. Our researchers are largely grad students and postdocs. They do experiments with many model systems, although no macaques. We do support them with bioinformatics, genomics, and biostats. This means, like many of you, we need to wear many hats. Puisque nous sommes à Montréal, je vais faire une présentation bilingue, mais je vais vous dire juste une phrase en français parce que mon accent est un peu dingue. I'm here today to talk about our challenges with code, which is so important as we progress down the research road. We found that most biologists can learn to use the command line for lots of bioinformatics tasks. That's dandy and fine. But for software that's released as a library, module, or package, one needs to use a programming language, which is more than some can manage. One specific example is the great code in Bioconductor. The problem is that writing in R is more than many can muster. We don't want to tell a biologist, you need to learn programming to run just one step of analysis. That's a lot of work, like maintaining one's spray tanning. Don't get me wrong, with the ability to code comes great power, but investing the effort to do so is not a task that all postdocs can devour. I should be clear, executing R scripts as independent commands, it's not something that only an experimentalist demands. Bioinformaticians can also benefit. You won't procrastinate. Instead of lengthy programming, every project you'll assassinate. To clarify what I'm talking about, I can use an example. Analyzing RNA-seq with DE-seq2. That should be more than ample. What if you want to look at differential expression and draw some nice plots? You could write some R code, but in how many lines? Lots. Or you can run a single command using your preferred options, which is just one of our many concoctions. The outputs are a summary table with a PCA, MA, and volcano figure. You can then go straight to the results and see if your method has enough rigor. You can always go back and change any desired details without writing new blocks of code or major risks of fails. For code that is generally useful more than once, we write a general script when we have the chance. If we can't already find a good source online, in between practicing a TikTok dance. We've been sharing the code within our group for years. It also helps us do tasks consistently without lots of tears. Everything we've written is available to our researchers and staff. They can reduce their analysis time. It makes them laugh. But why am I presenting this now? To make sure that you know, instead of at a previous ISMB meeting many years ago. The answer is we finally put a lot of our work on GitHub and have joined the Share Our Work Code with a World Club. Our repo adds transparency, removing redundancy with a knife, just like the clothes worn by Kanye's elegant wife. If you look at our scripts, you'll see a lot of Perl. I shouldn't be hiding, which means that some of us are oldish, although not like Joe Biden. Specialized figures like Upset, Sankey, and Waterfall can easily be created, even here in Montreal. We provide input, output, and sample commands, which are accessible by all. No one misunderstands. So the scripts on our website, these are our gift, even better than an album drop by Taylor Swift. All of this leads to an important question that's more general: how to work effectively as a bioinformatics team, not just in ways that are ephemeral. Our group of 5 wants to collaborate efficiently and consistently, sharing best practices and code, whether near or distantly. But how do we balance analytical consistency and novelty, encouraging quality, curiosity, and also progress velocity? When and how should we do all things similar ways with consistent logic, while keeping in mind the uniqueness of each person and each project? I don't have a good answer to this important issue. I'm always open to discuss what works for you if you wish to. Our BARC priorities include high-quality analysis and interpretation, starting with optimal design. It's almost always a challenge with experimental factors that intertwine. We also want to work efficiently, making the best use of our time, collaborating on projects, revealing biology in its most sublime. Thank you for giving me time as part of this BioInfo-Core session. As part of ISMB, a highlight of the bioinformatics profession, and the opportunity to speak among much more illustrious scientists, even if corporate attendees add us to their potential client lists. I presented our shared code and our rationale. That's a fact. I hope I haven't just wasted 10 minutes of your life that you'll never get back. Thank you, BioInfo-Core.